Here shows homework 6. Homework 6.1 is developing convolution function for input has indexing from 0 to the mx and impulse response 0 to the nh. So if there's two sequences given and you need to calculate the convolution, return it. To develop this code, you can use Excel or Python, whatever you can do, and then you can prove that by use of this example. Okay, how are you gonna do that? Let's see this. I would like to show you the pseudocode how to develop that one. You can see this is convolution operation, and let's think about if input sequence are given like this way. This is input sequence indexing from 0 to the mx, 0 to the mx. Then the convoluted output, the maximum index will be given by this index and this index sum. It means that if the final impulse response, if input is this one, then that will be reach up to nh plus mx. So output index will from 0 to the nh. nh is the impulse response are given like this way. Impulse response are starting from here to here. So this is 0 and the final index is nh. So this is maximum length for memory length of the impulse response from 0 to here. So the final result indexing will n can have from 0 to maximum mx plus nh. If n is out of this region, old yn is 0. Okay, then how are we going to calculate this convolution operation? Let's think about this one. Okay. So firstly, we need to draw the convolution operation. It means that if n is less than 0, okay, in this case out of this bound, the convolution will occur like this one. This is the index n. So in that cases, this point will be n minus nh. So in this area, yn is always 0, so we don't need to calculate in these regions. So similarly, the outbound of this one larger than this one also goes to the 0, so we don't care about those two conditions. Okay, this is always 0. So we only concern the in between these regions. So if xn is in between 0 and mx, then that case is like this one. N is larger than 0 and less than mx. In this condition, summation will be occur from 0 to n. So it will starting summation yn are given sum of indexing from 0 to n. The final value is n, starting is 0. That is this one. Okay, that's k. K equals 0 to n xk and h n minus k. Okay, this is okay, but the issue is this one. In somehow n is larger. If we take like that, this is n, this point is n minus nh, then summation should not starting from 0, it should start from here. So we can replace this part with k. The first value will be maximum of 0 over nh, n minus nh. The summation will start 0 or n minus nh. It depends on which one is larger. If it is something like this one, indexing starting from here, but it is like that, it will start from here. So we can choose one of these one. The maximum of this value will be starting integration, and the ending will be finished up to here. So this is the yn if n exists in this region. The second region, if n is larger than mx and less than mx plus nh, and satisfied in this condition, then we can think about okay, this color. It looks like this one. So this is n. This point is n minus nh. So summation will starting from here and ended up here. So yn are given from sum of the maximum is mx, and the starting will be normally n minus nh, and xk times h n minus k. Okay, it seems like to work, but in somehow this nx is very longer. It means if the impulse response is very long, then summation will look like this one. In this case, summation will start from 0. So sometimes it starts from 0. So we need to take a maximum of this one. So max of n minus nh or 0, we have the starting index from here. It's the same thing right here. Let's consider the ending summation index of n and mx. We know that the output will exist in between these index. All the other index cases, it should be equal to 0. So by summarizing these two things, the yn can be calculated in this way. Yn then yn are given sum of from here to here, that the xk h n minus k. So the issue is indexing. What is the starting point of the k? The k will start max over 0 n minus nh among them, and the finish value is also minimum of n over mx. So we can choose n over mx. Minimum value is the maximum integration, then, and also n will changing from n is in 0, 1, 2 and up to integer, and the final value is mx plus nh. This is final integer value. We need to calculate this one. To calculate this one, we would like to design a function convolution taking argument x and h. We need to design that kind of function. The x index starting from 0 to 0, 1, 2, 3, and final value is mx. And h, we need to figure out this one. 1, 2, 3, and 2, 3, and final value is nh. So we need to figure out what is mx and nh from after getting this argument, and then we need to calculate the output. Y sequence will stretch out from 0, 1, 2, 3, and final value is mx plus nh. So this is the range of each sequence, and then we need to make a loop, for example for loop if we are using the index n will starting from 0 to mx plus nh, and during this index changing we have to calculate yn. Yn should be accumulate all the history, weight the sum of the history. So to cover that one we need another loop are required. So here k are starting max over 0 and n minus nh. To maximum index is a minimum over n and mx. During this period we have to accumulate yn. Okay, we can rewrite this one. Okay, so yn should be accumulated, and this summation can be done xk times h n minus k. Okay, the product. And after accumulating all these three and index n starting from 0 to the mx minus nh, then we get the y stores the convolution of. We have to return, so we need to return y. Okay, this is a pseudocode. Based on this information we can make it work. So we can develop using the Excel or Python. Let's just start with the Excel. To code with Excel, you need to enable the development functions. I mean, here are development tools are shown here. To enable that one, you need to okay. Oh no, here. Okay, here. Okay, here you need to. Okay, this one. Development tool should be enabled at here. Then you can see these tabs. At these tabs, before that, to use the macro function, you have to choose extension with xlsm, and I would like to store that one in the homework 6. Okay, okay. I'd like to save that one. Then file name has extension xlsm. M means a macro. So without this extension you cannot develop by use of this one. So starting from the Visual Basic, Excel has built-in development tools, so you can using this one. Firstly, you need to insert. Okay, you need to insert module. Then this shows some blank code space, and here this is comment line. Convolution H. Okay, this is comment line. Firstly, usually I prefer to explicit declaration, so this is option, but I usually using this key. This key means every variable declared first. Okay, without this one you can using any variable without declare, but this option is better to debugging. First, I would like to, that when we taking the convolution sequence, that sequence stored in some variant. So firstly, I have to make a list from the selected value. So function cat variable function should be defined firstly. If any vector is given as a variant, a function also defined return value also variant. Okay, I defined. Okay, function variant function. Okay. This is so function is defined. Function is keyword and the function is another keyword. Cat variable, I define this one. V is argument but provided as a variant, and return value also variant. The variant means the array size is not declared at this times. So if function is given at that times, we can define the size of the array. I need to declare the variables, some output sequence as a variant I defined, and some range variable are defined here. Range variable. This is class object, and another dimension cell variable. This one is also another range variable. And for indexing, I defined index number as wrong. Okay, I declare the variables, and at this moment I defined the length of this one. So we define output from indexing from 0 to we have v is variable. The variant has cells, and the cell has a number of count, but the indexing is 0 to the maximum count -1. So this is the actual the dimension 0 to the up to this value. At here, this becomes the NH or MX for each cell in beta cells. Next cell. So all each cells, I would like to convert that value into array. Okay. Okay, and I is updated. When I get the variable from the Excel sheet, it has some variant variable. From that variable, I need to convert him into array variable, and that is this one. That array variable should be returned. To return that one, I need to assign the function variable name with the output. So if you assign in that way, this function is returned. It seems like a return function. So I define the converting from Excel the sheet range as a array number by use of this function, and I would like to calculate convolution function. Take x and h, two different variables. X as variant, another variant is h, impulse response. Variant. Okay, this is the convolution function. So I would like to find out array value of x sequence and h sequence, and ys sequence is the output. Okay, and I defined some indexing variable. One is at the current point, and k is a convolution index swing, and mx is a x sequence maximum upper bound, and nh is a impulse response h, upper bound is nh, and defined as a long integer variable. So first I convert the input x as array. So that one I defined this one, x. So x is passed to the argument for cat variable, and xs becomes a array variable. Hs also convert it to array. Okay, then I convert it to input as an array variable, and then I need to figure out maximum upper bound of access, upper bound access xs. Okay, and then nh is the upper bound of hs, impulse response indexing maximum value. This mx and nh correspond to this nh and mx, mx and nh. Okay, here so mx and nh are these two mx and nh value. hs and xs are actual sequence of input and input and impulse response. Okay, and I got the input and impulse response, then I can figure out the maximum range of the input variable. You know that output yn can take 0 to the mx plus nh. So the index range redefined ys from 0 to mx plus nh. Okay. Output can take from 0 to this value. That's the n can take in from 0 to the mx plus nh. That's this one. It's defined like that way. So output will take in that value. And the next one, look at the pseudocode. Okay, here. So I need two loops exist. First one is for n equals 0 to mx plus nh, and the loop is next n. Okay, this is the outer loop for this one, and inside of that another loop running for k starting the worksheet function dot max of 0 and n minus nh. So this is the starting point, and to minimum of n and mx. Okay, so this is also another loop. Okay, this is it. So I have two loops. One is the external loop, is n is shown here, and the k changing from this range, k changing from maximum and minimum. To using minimum, I have to attach worksheet function dot min. Okay, so this is it. So I define the range, and then I need to calculate ys. N is accumulated like this way, and x k times h. Okay, the index name is n, ys n plus xs k times hs n minus k. Okay, ysn is accumulated all the history by the weighting factor like this way, and then I get that. Okay, the calculation is finished. The next one is I need to update the result in the Excel sheet. To do that, I with application color and end with. Okay. If rows count is greater than 1, then ys should be worksheet function transpose ys, and I need to attach ndif. Okay, this is it. So this is the just the transpose. If the row is larger than 1, I can transpose that one, and then I need to update the convolution value returned ys. So I developed the convolution code by use of Excel VBA function, and then I can close this one. So I can now make in convolution. So the testing the shw06 to xn should be defined first. I think index n goes 0, 1, 2, 3, 4, 5, 6, 7, 8, something like that. And xn are given 0.3 minus 0.9, 1.0, and minus 0.7, and 1.2, and minus 2.5. Okay, at here this number 5 is mx. Okay, this one is mx equals x counting from 0 to the 5. 0, 1, 2, 3, 4, 5. Okay, 5. What about the hn? Hn is 1.0 and minus 0.5 and 0.25 minus 0.125. Okay, then nh is 3. nh is a 3. It's a stretch up to here. Here is ys. Then ys will starting from 0 to the sum of this one 8. Okay, up to here. Okay, this is the range. So output will stretch up to here. So I need to calculate convolution. I defined this function just before. This is the input sequence, and this one is output sequence, and closed parenthesis. And to operating the worksheet, you need to control and shift and plot enter. Control shift and take enter. Control shift and enter. Okay. Okay, I think this one. Okay, I think idx index. Okay, this is okay, stop. Okay, now it's working. So I check that one, and I will do it again, make it clear. Okay, we can safely close out. Convolution goes up to here, and I define the function. This is input variable x, and this one is h, and Control Shift and take enter, then it calculates the convolutional operation. This is the result of convolution. So I show you that this pseudocode can be implemented by use of Excel VBA function. You can try to use this VBA function. When you're using this variable, it means that when I'm using the convolution, I choose the range variable from here, P4 to the P9, but this range variable has a special class. So you need to convert that one into a array variable. So to do that, I defined these functions. This function just converting the given index variable like P4 dang dang P9, that kind of thing. This is the same C4 dang dang C7. That kind of variable should be converted into array. After getting the array, I define the whole range and the index range. As I told you that the index range are given from 0 to the mx plus nh. Okay, you can try out with Excel function. Excel has a very powerful the VBA functions. You can design the GUI and the high level highly complex functions also provided from here. Okay, you can see here that you can see these are the ActiveX controller or GUI widget also provided from here, buttons or scroll bars and checkbox, something like that. Okay, this is one of the methods to implement the convolution operation. The second one, you can refer to the Python tools. I prefer to use the Python in Python tools. Okay, this is it. Firstly, I need to change the directory, working directory at here. Then I have to create some files. The same thing can be developed by use of this the Python. This is pseudocode. I would like to develop that one with this function. So this one is a convolution function. Okay. So to develop that one, firstly I import numpy, and I define function convolution with x is input, h is impulse response. Okay. So I define the I need to figure out the mx and nh. So mx is a length of x minus 1. Because this is a counter, as we have done in the Excel. Okay, so we use this like this one. This is count minus 1. That will give mx or nh. So similarly, count number x count number minus 1. X will provide like this variable. So we have to counting this one. 1, 2, 3, 4, 5, 6. 6 count, but the index goes 0 to the 5. So we would like to find out the 5 number. It has a 6 count, but the indexing ranging from 0 to the 5. So minus 1 is added like that. And similarly, nh is the impulse response length, h minus 1. So I figure out the x and h counting number. And then ys output sequence will be given firstly initialized. So it is a number of count should be provided. So mx plus nh plus 1. This is number of count for output. So by this count, the index number goes 0 to the mx plus nh. That's the range. Okay. So now I can try to develop this part. So for n will changing from range 0 to the maximum index is mx plus nh plus 1. This is the maximum range indexing. So that's the outer loop. Okay. In the range indexing, the range take a count, number of counts. So I added one more variable right here. And the next one is k will change max of 0 and n minus nh to min mx plus n, the minimum value. That's the this part. And because this is range variable, I added one more count. And then I can write down the convolution operation. So is output sequence are accumulated, and xk times h n minus k. So this one is convolution operation. Okay, so this is the end of the convolution. So return ys. This is the convolution function. So I would like to save my convolution Python. Then it's stored like that. Now I would like to testing that one. So import my convolution. Okay, and then I define the input variable. Okay, I think. Okay, x np dot array 0.3 minus 0.9 1.0 minus 0.7 and minus 1.2 and minus 0.5. Okay, this is it. Okay, x is this one. Length of x should be 6. Okay, 6 count is 6. And then I define the h variable np dot array 1.0 minus 0.5 and 0.25 and minus 0.125. Okay, this is h. So length of h should be 1, 2, 3, 4. It should be count 4. Okay, this is it. And then I can calculate convolution. So ys are my convolution function x and h is argument, and calculate that one. Okay, there is some problems. Let's see. What was the max? Range max 0, 10 minus h. Okay, this is not plus. It should be select one of them. Okay, I figured out the wrong thing. It's not the plus. It should be we have to choose one of these two things. Okay, my fault. Okay, try it again. Okay, to figure out, I restart that one. Okay. Okay. I think this is better. If name is main, then I can add the testing sequence at here. X sequence are np.array. Okay, here it. Okay, 0.3 minus 0.9 and 1.0 and minus 0.7 and 1.2 is minus 0.5. Okay, this is input X sequence. Impulse response is np times array 1.0 minus 0.5 25 minus 0.125. Okay, this one is the impulse response. Then I can get the result by a convolution of x and h in the print file, and save and run. Okay, convolution. Okay, run. Okay, I got that. So this is the convolutional result. I need to check up that this is correct one or not. To do that, I can refer to the MATLAB code. I prefer to use Octave instead of MATLAB, but it's compatible. You can use the MATLAB. The Octave is this one. You can install the Octave if you didn't install the MATLAB. But if you have MATLAB, you don't need to install that one. If you run that things, okay, it didn't work. Okay, I run the Octave tool, and here this is command window, and this is editor, and this is help statement. So okay, I just checked that the convolution is correct or not. So to confirm that one, I defined xn like 0.3 and minus 0.9 and 1.0 minus 0.7 and 1.2 minus 0.5. Okay, this is x. And impulse response is 1.0 minus 0.5, 0.25 minus 0.125. Okay, this one is impulse response. So I have impulse response and x. MATLAB has its built-in convolution function. Okay, this is convolution function. You can using convolution between these two input sequence. Okay, and y are equal convolution x and h. Then you got the result. Okay, here it is this sequence. Okay, this is the sequence from MATLAB. Yeah. And this one over here. This one is a result from the MATLAB. What about the Python? So this one is a Python code 0.3 and minus 1.4. Okay, check up that one. It's a correct one. Okay, it's correct. What about the Excel? This one is I can extend. What is it? 4. Okay. This one is okay. Copy and paste. Oh, it didn't work. Copy and paste. Something different. Okay, I copy and paste. You can compare that, the result. It's 0.3 and yeah. The end of it's a little bit different. I'm not sure the reason why. 625, 625, 620. I need to check it. The reason why. Because of truncation. Okay, this is not 25. Okay, sorry. This is 25. Then we can get the correct result. Okay. I have to delete this one. This is correct one. So you can compare. All these results are correct. Why you have to submit that one? You can you need to submit one of Excel or Python code. You can do one of these two things. When you're submitting the Excel, you need to submit this file. Okay, or if you would like to submitting Python code, you need to submit this one. And finally, you have to suggest the result calculated from the MATLAB and confirm that your calculation is correct. That is this one. So you need to compare the result. If you have done with Python, you can compare this one with the MATLAB result. Or if you have done with Excel, you need to compare this one with the MATLAB code result. Is the correct one or not? So when you're submitting, you can make a simple file like this one, notepad. You can compare the result like this one is copy and from MATLAB. Okay, this is MATLAB. If you solve with Python, then you can copy and paste that one over here. So check that. Check out the match. Okay, this one is from Python. Or you can compare with Excel. You don't need to both of them, but if you have Excel result, okay, you need to compare that one. Okay, you need to compare the result with okay, this one from Excel. Okay, this one come from the Excel, this one is a MATLAB, this one is a Python. You can do one of the Python or Excel. You can do one of them. Okay, and you have saved this file at this folder as a report. Okay, then from the file, you can write down this one is shw06-2 report. If you have done with Excel, you can add this one like this one, 0.1. So okay, it's still opened, so I have to close out. Then okay, if you have done with Excel, make a zip, then you can upload this one into through the HISNet. Okay, so that is the homework 6.